Cool. Hi everyone. Thanks for coming on time, and sorry for the issues. I feel like my laptop's probably locked down more than I think, and every time I go to present, the MacBook is like, nope, you're not showing anything, I'm sorry. So that's probably the issue. So next time I'm going to bring a different laptop. We're going to talk about GitHub Actions. So one thing right up front, this was not originally a talk I was going to do. We had Lachlan from Rome to Rio who got sick and pulled out last minute. I thought, it's an Actions talk, that's fine, I can just deliver your Actions talk. Just put my name on it and I'll just deliver whatever he was going to deliver. And then I looked at the abstract and it was about how he had migrated 127 Azure Pipelines to GitHub Actions and talking about all the things that were good and horrible about that. Now, GitHub pays my salary, and I don't want to dwell on the stuff that's horrible about that, but I definitely will be talking about that. So I spoke to him about the challenges that he saw with that migration and the gaps between the products, and I want to be honest about those gaps as well. So I'm going to go through GitHub Actions. We're going to look at what it can do and how you do it, but I'm also going to talk at the end about some of the gaps and what that migrating story looks like if you're on Azure Pipelines. And peripherally, if you're on something else as well, there's some tools that can do it from a lot of different locations. So we're going to talk about what it is, using it for CI/CD, which is kind of the standard use case, but also using it for non-CI/CD. So Actions is a great automation platform for anything. You can basically do anything in response to anything, and we'll see how that works later. And then we'll look at migrating. We'll look at what's new in GitHub Actions and what's coming in GitHub Actions. And if we've got time for Q&A, we'll do that as well. All right. So GitHub Actions is kind of, it's promoted as a way of getting your ideas into production, essentially. And we talk about these workflows for getting your idea to production. And most of the time when we talk about these workflows and these pipelines and things, we're talking about when you commit your code all the way through your environments into production. But Actions is actually useful for far more than that, for the earlier stages as well. So internally, we use Actions constantly to triage issues and to work with our project boards and things like that. Make sure that pull requests have the right information in them before we even think about merging them back into our main branch. So Actions is good for not just the CI/CD part, but a lot of the DevOps lifecycle before that as well. In general, yeah, it's a very open automation platform that can do a lot of stuff. We've found, and we look at this data internally as well, because we have this metric which is I2D internally, which is idea to data. So when we release a product, we measure the time it takes between the idea that we had about this product to some data from production telling us whether that idea was a good one or not. And so we collect a lot of that data about whether our features are more effective for people, or whether when somebody turns Actions on, how successful that's making them, or is it slowing them down. So we found that people who use GitHub Actions merge their code one and a bit times faster than people who aren't using GitHub Actions, and they merge more pull requests too. So just on that pull request side, on that merging pieces of work into their main branch, we find Actions is really handy for that too. We find that people who are using tools like Actions, and this is a bit more generic, that automation in general can help with this DevOps lifecycle. And if you have this automated pipeline, CI/CD pipelines, you're deploying code more frequently. There's a faster commit to lead time, so kind of a little bit in from what we measure with the idea to data, but commit to production, that time is much, much faster. But importantly, if something goes wrong, because things always go wrong, we can recover a lot faster because we have that pipeline that can push fixes out to production really quickly. GitHub has a twice daily release train. So we have a large number of engineers, in the many hundreds of engineers, and so we don't push out every single change to production. We queue them up and put them on a release train. There are a lot of checks and balances before it gets into that main branch. They're fast, like you can commit something one day and it will be in production within an hour. But it goes on that release train, we release all of those things out to production. So if something goes wrong, we can queue a new release train. We can fix that issue and queue the release and it can go out immediately. So in general, using tools like GitHub Actions and good DevOps practices mean that you can fix issues when they happen faster. All right, so let's look at what Actions can do. And I think at this point, it's a good idea to kind of leave the slides for a little bit and talk, like kind of show you how to get started. Now, Actions is part of every repository. You get a certain number of free Actions minutes for everyone. So on the free plan, I think it's 2,000 free minutes per month. Minutes aren't necessarily charged by the minute, which is very confusing. If you are building on a Ubuntu machine, then you use 1 minute per minute. On a Windows machine, it's 2 minutes per minute because it costs us a little bit more to run. If you want to run it on a Mac, it's 10 minutes per minute. So, you know, about similar to the way that the prices of the devices worked. Yeah. So to get started though, in your repository, you can just go to Actions. So let's just jump out of that for a bit. And I'll see how well I can do this. All right, here is my, let's get rid of the stuff tools. Here is my github.com. And I'm going to go to Demo Visa Inc. .NET Web. Yep. I think when I cancel things, like swap between presenter mode and the other mode. So when we go back to the slides, I'll just go into the PowerPoint thing. You can see all my plans. There we go. .NET Web. All right. So this is my little project. We've got a number of actions set up already. And what I want to do is kind of walk through how you get started, and then we'll look at some actual actions and what they can do. So you can see I've got a few already set up. We'll look at those in a sec, but for the moment, I'm just going to click on New Workflow. Now, GitHub Actions are powered by workflows that you design or you write that live in your directories of your repository. So the definition of what you're building, that workflow definition, lives inside your repository. So when we grab these, we will be ultimately just creating a YAML file in our repo. GitHub notices that YAML file and says, okay, I've got a new definition, a new workflow definition. This starting page has been updated relatively recently in the last several months. It now looks at your code and makes suggestions. So this is a .NET project and says, well, .NET's probably the one you want. Or if you want to deploy, you can do a .NET Core app to Azure Web App or ECS or GKE. If you want to do security, you can do some CodeQL analysis. And so these templates will kind of get you started. And they're a little bit more targeted than what they used to be. It'll look at your code and make real suggestions. Let's just configure the standard .NET one. And you'll see straight away, how's the zoom up the back? Can you read that? Great, okay. We can see straight away, it's saying to me, look, we're going to create a file in the .github/workflows folder. And that's where all of my workflows live. They'll all live in that folder. At the moment, there's no folder structure, so I can't go a folder underneath that and have packages of different workflows, which is generally fine for most people. I mean, most projects are unlikely to have more than maybe half a dozen or so. Some will have lots more. GitHub. So when I refer to GitHub, I mean the repository that we write github.com on. It's a mono repo. It's about 11 gig in size. It's written in Ruby. You can pick any of those things that I just told you to wonder what we're doing. It's been around for a while. It has like 50 in there. So managing our workflows is a little bit tricky. So just to be perfectly open about that. And then in the file, we have this really nice editor. So this default one, we give it a name just so we can identify it. It doesn't have to be unique, this name. The file name does, obviously. And then we have a series of triggers. So events, there are a lot of events in GitHub that will trigger workflows or can trigger workflows. In this case, we're triggering it on a push to the main branch, and we're also triggering on a pull request that goes to the main branch. We can also do things like, say, we want to push to the main branch, but let's just see what the keyboard shortcut is here. There we go, Control Space. There are other things we can specify as well. So if I want to ignore things in my docs folder, for example, you know, I can say anything that's in the docs folder, ignore that as well. I'm not sure I've got the syntax exactly right there, but so you can customize these a lot. You can say everything except for these branches. You can give a branch pattern as well. So everything that's a feature branch, for example, that's prefixed with feature, that'll trigger it. And for some of these triggers, there's a lot of customization you can do. For example, you can put a trigger on an issue when the issue is created or when it's had a label applied or a specific label applied, when it's been added or removed from a milestone. There's a ton of customization you can do with these as well. There's two special ones too that I want to talk about, actually three, but two main ones. And they are workflow dispatch and repository dispatch. Now, let's do that, repository dispatch. So I'll try and make sure I get these the right way around. Repository dispatch is, I believe, when it will give you an API endpoint, I'm pretty sure. Got some people nodding. I always get these two confused and I have to look them up every time. So that repository dispatch will give you a button, I think, or workflow dispatch. Workflow dispatch will give you a button that lets you click. You'd think somebody who worked at GitHub would know this, wouldn't you? So you can manually run that workflow. You can also ask for inputs. So you can define inputs that need to be provided when you click that button. So things like, it'll always ask you what branch you want to do it on, but you can do things like, you know, a yes or no whether I'm going to go to production or not, or a version of a dependency that it's going to pull in from a package manager or something like that. So that's clicking the button. Repository dispatch, which is definitely the one I didn't say before, right? Repository dispatch is the same thing but API driven. So you hit an endpoint and it will fire that workflow. Again, you can provide inputs. They're just in the body of the HTTP request, and it will fire them off. So that ultimately means you can trigger it based on a manual click, or you can trigger it based on anything in the world hitting an HTTP endpoint. So if you have a third-party service that needs some sign-offs for something, and then they do get the sign-offs, as long as they can hit a URL, you can fire off an actions workflow. Cool. Then we have our collection of jobs. I'm not going to save this, so I don't know why I'm making sure I get all the syntax right, but we have a collection of jobs. Now, jobs by default will run in parallel unless we tell them not to. So here's our build job. You can name that whatever you want. We tell it what it will run on. So in this case, we've chosen Ubuntu latest, but there are a lot of options. Will it autocomplete this one? Nope. I thought it did. Ubuntu latest, there's Windows latest, there's Ubuntu specific versions, there's Mac OS specific versions. We just released Mac OS 14, I think, as a runner. And so these jobs will run on a runner that has that definition. Now, the important thing to realize is each job will get its own machine, its own infrastructure built to run that job, and then it will tear it down completely. Which means if you have a job that does your build, compiles your code, gets some lovely deployable assemblies, and then you don't do anything with them in that job will disappear. Like the runner will completely disappear and you'll lose all of that information. So in a job, if you want to keep that, you need to upload it. Now you can upload to the workflow run just by uploading the artifact, or you can upload it to a package manager or a container repository or anything like that. GitHub Packages is also part of GitHub as well, and that's convenient because the auth just works. You know, the actions workflow runs in the context of or runs in a context where it can talk to GitHub Packages if you let it as well. But you could push it to Docker Hub, you could push your packages to anywhere. If you're using something like Octopus Deploy or a product like that to deploy the application, you can also just push that package straight to Octopus, and then Octopus can take over from there. So tons of stuff you can do. But yeah, it's important to know that those jobs will run in parallel unless you tell them not to, and they will also just be torn down at the end. They're ephemeral, essentially. You can also do self-hosted runners. So if you have a machine that you need your job to run on, you can self-host that runner. Now, the options for the hosted ones, GitHub hosted ones, we charge you per minute, or we take away from your free minutes and then we charge you per minute. If you have self-hosted runners, we don't do that, but there are restrictions on how many things you can run in parallel. They're very large numbers. Like if you run more than 500 jobs in parallel, then we're going to tell you not to. But if you want to run on your own infrastructure inside your own network, you can do self-hosted runners too. There are a lot more options for those as well. You can basically have self-hosted runners for any number of operating systems and platforms. I have compiled that. At the time I had to compile it, I don't need to anymore. I've run a GitHub Actions runner on a Raspberry Pi before, and so it actually does the job on the Raspberry Pi. It's really good that those runners also punch their way out to GitHub to communicate, so you don't have to worry about opening firewalls. So your production machines can talk to, your production machines will talk to GitHub, not GitHub talking into your production machines. Kind of works in a nice way. If you use Azure Pipelines, that's pretty much exactly the same way that Azure Pipelines works for their self-hosted agents. The reason is that they're basically the same thing. Like the code base, GitHub Actions forked the Pipelines code base for the runners. And in fact, the definitions of the machines themselves are pretty much identical. If you drill down in the docs to see exactly what's on these runners, it'll ultimately take you to a Microsoft page that gives you the definition of what's on those self-hosted runners, what's on those GitHub-hosted runners. So yeah, all of that's available. There's a ton of stuff that actually is on these runners, and then if you want more stuff, or you want it inside your network, you can do self-hosted ones. Right. So then we have our collection of steps. Our steps are basically the things that we want to run inside that job. And there's two main types. There's actions, and so these are kind of self-contained collections of things that you want to run. So in this case, we've got an action at the start to check out our code. So we don't need to worry about running a git clone or anything like that. This action will do that for us. We've got an action setup.net. So that is provided by GitHub Actions. And we're passing in some arguments like, what .NET version. But then we've got a bunch of run statements, and that's the other type of thing that we can run as a step. And those are basically just scripts that'll run. Now, we're on Ubuntu latest, so it'll run them by default in Bash. If we're on Windows, I think it runs it just on the command line by default. You can have a bit more control over how that works, like what it runs on. You can even tell jobs to run inside containers that are hosted on here, and then define the container that you want it to run in if you want kind of real control of what's running inside that runner. You can even have jobs running containers that contain services that that job might need. So if you wanted to do a job that does a lot of testing and you need a database behind the scene, you can set up a service container that runs alongside that job or alongside that runner and open some ports and talk to it that way. We're getting a little bit into the weeds of what stuff you can do. My point is you can do lots of things. You can run actions which do things for you, and you can run scripts that'll run just on the platform that that runner is running on. To find these actions, you can see in this editor, they're over on the right, so that marketplace thing is built in. If you want to find them in the marketplace, all the way up the top of github.com, there's a marketplace. Now, when I wrote this talk, I think there were 13,000 something actions. There you go. It's only gone up by 10 since last night. But when I delivered this talk about a month ago, it was around under 13,000. So there's a lot of these all the time, and they cover everything you can think of. The great thing about these actions is if you want to do, I don't know why, there you go, first interaction, there you go. So when a new contributor leaves a comment or something like that or creates an issue, if we want to see how that works, that action works, and this is true for any action in that marketplace, the link will be to that repository. And that repository contains all of the code that is executed with that action, including all the metadata to define that action and everything like that. So if you find an action that's close to what you want, but not exactly what you want, then you could just go to this repository and fork it and make the change yourself, And then you can run actions not just from the marketplace, but you can run them from inside your own organization as well, if you can point at a repo. So everything is open here. Any action, you can see exactly what it does. All right. So yeah, we have a bunch of those. When we want an actual CI/CD pipeline, the general thing that we want to do is have a step at the end of our build job to upload an artifact to somewhere, as I mentioned, and then our subsequent jobs, using the whole strategy of build once, deploy many, we can do something like staging as a job, and then under staging, we have needs, I think, as long as I've got that right. Yeah, and we can say it needs the build one. And that means that these two jobs will run in sequence. So that staging job will wait for the build job to succeed, which means we know that artifact is going to be uploaded. We can pull it down and start doing our deployments. We're starting to get a little bit deep into kind of how to construct these. So let's look at one that I've already done. So you're not watching me fat finger the keyboard that I'm not used to in an operating system I'm not used to. So let's have a look at this CI/CD pipeline that we've got here. We're going to look at the result of this first. So what you actually see when it's complete. You can see, you get the tie all the way back to the commit that triggered that, workflow run. We can see what happened, the success. We can see there is an artifact that was uploaded. So we did exactly what I was kind of talking about. We did a build step, and then a staging deployment, and then a production deployment. That production deployment stopped and waited for me to approve it too. So you can see here there was a deployment review for production where 23 hours ago I said, yes, this looks good, clicked a button, and then it continued onto the production environment. And then we can see our artifacts. We've got a 349 kilobyte web application here, .NET web application. So if I wanted to, I could just pull that down. You can set up retention periods and things like that on the artifacts too, so they're not going to live forever. You also get a certain amount of storage depending on the account that you use. So a free account, I think it's 50 gig. I'm running from memory there, I'm sure I could look it up. All the way through to an enterprise one, which is something like 500,000 gig, or I don't know, something ridiculous. Anyway, so the storage costs apply to those artifacts, and so you can set retention periods after which they're deleted. Yeah, so that is that process. The actual YAML for this, we can see that workflow file to see what it looks like. And it's very similar to what we just saw, right? It's going to trigger on a push to my main branch. There's a build job running on Ubuntu, which does a checkout, a setup.NET, a build with .NET, and a publish. It'll upload the artifact, and it'll tell it, this is what I want you to call it, and this is where I want you to get it from. Our staging step needs the build step. And in this case, we're saying we have a user statement. So one other thing that GitHub Actions can do is it can have reusable workflows. So because we're deploying exactly the same way in staging and in production, there's no point having all of those instructions twice. So instead, we've outsourced that or put that in another file, which is published to azure.yaml. And so that will point at another file, which determines how to deploy it to Azure. And again, we're kind of passing in information. We're passing in the environment name we're going to, the URL, this slot, which is something that deployment needs for Azure, because we're deploying it to a web application slot, and then the name of the artifact. We're also passing in some secrets. So one of the things that GitHub Actions has is secrets management. So any things like Azure publishing profiles or API keys, you can keep them in secrets. Now, secrets can be stored at the repository level, at the organization level, this is for actions, or they can be stored at the environment level. So when you do a deployment, you say, I'm deploying to my staging environment, and that staging environment will have its own set of secrets. So if you're deploying to staging, it'll use that value. If you're deploying to production, it'll use the production value. For those familiar with Octopus Deploy, that'll seem really familiar. Same with Azure Pipelines, I think. That'll seem like a really familiar way of working. And so we're passing in that information. Secrets, by the way, are write-only. We cannot get them back out. So if you look in the UI at those secrets, there's an update button and a delete button. Even GitHub can't get those out for you. So if you have something very precious in there and you forget what it is, sorry, it's in a locked vault that even we can't undo. It will be masked from the logs as well. So if you echo it to the log, you can't get it out. Now, I think if you're really tricky, you might be able to do some substrings on it and get chunks of it out. But I think we try to stop you from doing that as well. I just don't know if we can catch every instance of it. So if you really, really want to get it out, you probably can. But in general, we try to protect that as much as possible. All right. So we've talked about secrets. One thing I haven't really, so we have our staging one that needs the build, and then we have our production one that needs staging. The approvals process, though, is based on those environments. So we can predefine those environments or go into here and say, these are the environments that I want. And we have our staging environment, which has one secret, which is our publishing profile. And we have our production environment, which has a secret, but also 2 protection rules. So whenever we deploy to production, we've got here that I am a required reviewer. I'm also the only person on this project, so it's not really realistic. But you can say a person or somebody from a team has to approve this before it goes to that environment. You can currently set a wait timer to say you need to wait at least an hour before going into production. If you're familiar with Azure Pipelines and some of the other tools, this may not seem like a lot of options. Azure Pipelines has automated gates. They have a ton of other things that you can put in there to stop deployments or to wait until something happens. They don't really exist here. There are ways you can use the API to do the sign-off for you if you wanted to do it with a third-party service. So just wait until a person or a service account kind of approves it and then use an API externally to say, okay, approve it. But you're going to do a bit of work yourself for that. So if there's more than this that you need, Azure Pipelines or some other tools might be the better way to go. We also have a rule on only deploying to production from protected branches. So in this case, we are protecting our main branch, which means nobody can commit directly to our main branch. They have to go through a pull request process. And we're saying that you can only go to production if you're coming from a protected branch. In other words, one that's gone through a pull request process. All right. And then our environment secrets. So we've got our publishing profile for the production environment, and that value will be different than our staging environment. So we can do our protection that way. Cool. Make sense? So this is kind of how we do it for CI/CD. You know, we have our jobs that run that depend on each other. Our first job will do our build, upload the artifact, and then subsequent jobs will pull down that artifact and do the deployments. Actions will let us deploy kind of to anywhere. If you do a search for AWS, there'll be a million things that come up. If you do a search for Azure, there'll be a million that come up. Look for the authors that are verified authors. So if we have a look at this Actions one, let's see if we can jump back. Verified creator, because this one's from GitHub Actions. Some of the other marketplace ones will be from verified creators as well. So if we did like Azure, we can see there's a little tick next to the Azure one. They're provided by Azure. There'll be ones for AWS, anyone. That's some indication that it's coming from the company that you would expect it to, but we don't check every single action. We verify creators are who they say they are, but we're not going to guarantee that somebody at that company who has the keys is going to put something malicious in an action and upload it. Trust me, if that happens with a popular action, we will find out about it really quickly. There are more than 200 million repositories in GitHub at the moment. So if somebody does it, you probably won't be the first ones hit. It hasn't happened to my knowledge that I've seen yet. I'm just saying it. You need to, if you really, really care about what's in that action, have a look at the repository and see what it does. You can also pin to versions. I didn't really highlight that. But in general, when you say I'm going to use an action, so action/checkout, there's an @v3. And so that is any kind of Git tag, I think. So you can point at a version, that's v3. You can point at an individual commit or a branch or something like that. So yeah, pin your versions for stuff you care about too. That way you won't be surprised if somebody upgrades their action to something malicious. All right, cool. So this is the CI/CD side, right? Where are we for time? Okay, let's talk about non-CI/CD. So rather than kind of walk through everything, I'm going to show you and this is going to ask me to auth again, I bet, but github.com/github/IRL. So IRL is a repository that the developer advocates use. The dev advocates use inside GitHub. Oh man. Let's see whether we really want to bother with this. No, that's going to be a massive password again, and you've had enough of me typing. Let's look at another one. It's a repository that we use to track events, so in real life events that we're going to sponsor or attend, right? We use the issues to track those events, and we use project boards to move them around and triage them and things like that. We have an actions workflow that we wrote that will run when an issue is created. And when that issue is created, it will parse through the contents of that issue, that request, and it will pull out information about what month it's in, whether they're asking for swag or sponsorship or a speaker, and it will apply labels appropriately. It'll even take that whole issue and reformat it completely so that it's not so noisy. It just puts a lot of stuff in a table. And then it will put it on our project board under the triage column to make sure that we get working. Things like that happen across GitHub everywhere. We use actions to automate tons and tons of stuff. It's really useful for doing things like parsing issues to make sure that it has all the required information, the stuff that you really want, for moving things around boards, for reminding people when deadlines have passed for issues that are already in there. It can even do things like, so one of the other things that's really common is pull request checks. So making sure that a pull request actually succeeds when it runs through a build. So I think I've got in .NET Web, there's probably one there. If I look at pull requests, anything closed, yep. So I think we've got a PR check here. Nope, no PR checks. So what you can do on a pull request is have a series of actions workflows that will run, and you can even set them as required. So this job needs to succeed, otherwise I can't merge back into my main branch. So it's not really CI/CD, but it's kind of a build that happens beforehand. You can check anything based on anything. I've run demos before where I let people write a comment on an issue, and then if it's got a hex color code in there, it will pull that out and then go and talk to my light globe behind me on my desk and change the light globe to that color for 10 seconds. So you can do anything. You can talk to Slack, Teams, whatever you want. Frivolous things, but also things that can really help with your entire software delivery process. So triaging issues is a great way of managing this, and it speeds up your entire DevOps workflow. It's not just the CI/CD, you can do a lot of automation all the way through. So hanging that on GitHub on Actions is a great way of doing it. All right, the reason you can do almost anything for non-CI/CD is because there's all of these available events. I kind of touched on this before, but this is the list of events, and inside most of these events, there's also additional filtering. Some of them are a little bit weird, like Golem, I think, is if there's a fork of your folder or something like that. What is it, sorry? The wiki, that's the one, sorry, yes, you're right. Yeah, Golem is if there's a change to a wiki or the wiki created or something like that. You can, like when somebody forks your repo, you can send them a message saying, thanks, make sure you give me credit when you do something with this. And you can also do schedules as well, so you can just run cron jobs. So every hour or every day, you can run a process. That one's really useful for looking at deadlines for issues, or whether this issue has been sitting there for a very long time without a comment. We use that internally a lot as well. So many things you can do. And of course, the number of actions that you have available means that you can do almost everything as well in response to these. So extremely flexible is my point. So a little summary of GitHub Actions just before we talk about the migration thing. They're defined in YAML. Those YAML files live alongside the code in the repository. If you branch, you create a feature branch and change the way your application works and therefore change the way it builds, then you can change the pipeline code, the workflow code, alongside that change. So that's one advantage. If you change the way it works, you can make that change in the branch. You don't get that situation where it doesn't build for a while you're syncing the build definition and the code. The other advantage is when somebody forks your code or somebody clones it, not only do they have your code, but they know how your code is built because that's in the repository, that definition's in the repository. You can obviously trigger on any event. You can run on GitHub-hosted Mac OS, Linux, Windows, and also self-hosted runners, and you can even go a bit further and run them inside containers inside those runners, and you define the containers. There you go, 13,800 plus actions at the moment, and that's growing all the time. Environments and approvals means that you can have this deployment workflow and approve it between your staging environment and your production environment appropriately. And then, managing secrets as well. So you can make sure that that secure stuff that you don't want in your repository will not appear in your repository. Cool. So that's what it does. The original talk that was going to be on at this time was all about migrating from Azure Pipelines. So I've done one or two of those. In general, I kind of like to start from scratch a bit, but that's certainly not a solution for everyone. Especially if you have a huge number of workflows or some complicated workflows. So I asked Lachlan what he thought was good and bad about the process that he went through of migrating 127 of these workflows. Not just good and bad about that process, but being in an Azure Pipelines environment and now moving to GitHub Actions. What are the good things with Actions in comparison, and what are the bad things with Actions in comparison? And I want to be completely honest with you, so I'm going to tell you all the bad things, and I'm going to talk about why, and hopefully some workarounds and things like that. So, some things to understand. Things work differently, especially around deployments. In in Azure Pipelines, the gates and the approvals happen before an environment or after an environment. They're not technically attached to that environment. So if I deploy to production, I can put a gate before it goes to production or a check before it goes to production. But the production environment is its own thing. That phase is its own thing, right? The check happens before it. In GitHub Actions, the environment has its protection. So the checks are appropriate to that environment. So whenever anything says I'm deploying to production, those checks will apply. So it's just a different way of handling it, I guess. There's also only one spot where that happens. It's to do that deployment. In Azure Pipelines, you can say, do it before that environment and do it after that environment. The scenario for that would be, if you have a QA environment, a QA team has to do an approval before it goes into their environment because maybe they're testing. And they'll say, okay, that's great, that can go. And then after it goes to that QA environment and they've run their testing, they can release it from that environment and say, okay, everything was great with testing, I'm going to approve it to go to the next stage. So you get this kind of one on each end. So environments and approvals especially works differently. And we saw as well that the capabilities around the approvals are not as rich as they are in Azure Pipelines. So automated gates is a lot harder. And things like timeouts or waiting for a particular time of day to do the deployment is not something you can really do in GitHub Actions. I think you can do it in pipelines quite well. We've actually got a lot of docs on migrating, and this is just a screenshot from the docs. It's incredibly easy to find, docs.github.com, and then search for migrate. And so these aren't just, this is what you do, but there's a lot of documentation in here about these are the differences between the two tools and the things that you need to understand. So it's got one for Circle CI, GitLab, Jenkins, Travis. I think those are the only ones we've got in there at the moment. So that can be really helpful as well. If you're migrating those workflows though, you might think, well, Azure Pipelines is defined in YAML as well, right? What's the crossover between the two? well, they're different YAML formats, right? They're different schemas. They're not too far off each other, which means that there is some tooling that can do a pretty good job of translating. This pipelines to actions.azurewebsites.net was written by a GitHub employee, Sam Smith in New Zealand, and it's actively maintained. It's open source as well. It runs on an open source package that does that translation. And he's tried to translate as many of the common actions as possible. So the way you call the step in Azure Pipelines has a kind of an equivalent in GitHub Actions. And so it'll translate those actions or those steps to actions quite well. That does a really, really good job, especially if you're not doing anything super funky with the way it works. So have a look at that if you just want to convert one across. If you want to do a lot more migration, not just from Azure Pipelines, but from Azure DevOps or from the Atlassian toolset or any of those other ones, there is a tool called GitHub Valet. Now, there's a repository for it. I don't have a link for it on here because you can't just get it and run it. You've got to talk to our sales team about getting that set up for your org and helping you run it. It's not download the thing and run an executable. It's a lot more complicated than that, and we don't want you to destroy your repositories. So we want to get involved in that migration process. Also, probably, I don't know for sure, but I'm guessing it's probably not free to do it. So, but if you want to migrate a whole lot of stuff, Valet is a way of doing it. If you look that up, you should be able to find the repository. Or talk to me and I can give you a link. So the things that Lachlan said were good about GitHub Actions in comparison to pipelines. He said the speed of actions is really good. And this is his words as well, he said it's really fast. He said that the Actions marketplace is fantastic, especially the fact that you can see exactly what every action is doing. Like they've got an open repository for all of them, so you can see exactly what happens. The runners kind of behave in a very sensible way. The self-hosted ones are easy to understand. Sorry, the hosted ones are easy to understand and the self-hosted ones are easy to install. The fact that they punch their way out through, out from your firewall into GitHub is a nicer way than asking you to open ports and things. 3 minutes are good. Pull request checks, which we didn't really look at because I couldn't find a great example without typing in 1,000 characters. Pull request checks are great for making sure that your main branch is relatively protected. There's a good API that I haven't talked about at all. There's actually 2 APIs in GitHub, which is the REST API and the GraphQL API. Now, they don't both cover everything. Some things are only in the GraphQL API, like the issues and project stuff, I think is only there. It's not in the REST API. Actions, I think, is in both. So you should be able to use both APIs to talk to actions and do some things with the workflows. So that's there. He said the documentation's really quite good. There's a lot of focus on the documentation at the moment, I think, of telling you what things are and not necessarily how you fit things together. And we're trying to actively change that. There's the list of events that trigger actions. It tells you a lot about that event, but it doesn't really go through when you might want to use it and some use cases for making use of it and things like that. We are working on that. Things that are bad, I don't know why that's green. Things that are bad. Native support for a lot of functions inside GitHub Actions isn't there. There's kind of a tendency at the moment for us in our team, we've got a ton of stuff that we want to do inside GitHub and inside GitHub Actions. If there is a solution that the community has come up with, then that goes down our priority list to add native support. One really good example is a repository or project that somebody's written called Nektos Act. So it's github.com/nektos, NEKTOS/act, ACT. And it's a way of testing your GitHub Actions locally before having to commit them to a repository, which is something we get asked for all the time. But that tool does a really good job. Now, we support that product or that project in a lot of different ways, but it also means that we're not building that internally because that's a thing that solves the product, or solves that problem for us. Whether that's a good thing or a bad thing, right? The project's out there, we're not, clobbering it with our own. I suppose you could say that's good, but also we're not building these tools in locally. There's some things like the extra approval steps and so on. We're like, well, the way to do that is to use the API to do this and do this, but you're going to have to do a lot of that work yourself. There's a solution. It's not great, but it means that it goes down our priority list. So that's one of the things. There's a few things where he had to do a whole bunch of work himself rather than natively supporting that in the product. The deployment capabilities are pretty basic. You have an environment that you deploy to, and it can depend on another environment, and there are some pretty basic approvals processes. But beyond that, it's fairly basic. If you wanted to deploy, for example, to a suite of web machines running IIS, there's no way at the moment to say, run this job on all of those machines, like there is in Azure Pipelines with deployment groups. GitHub Actions will just run that job on one of those machines. If you want to do multiple, then you have to either use a matrix strategy or something like that to say, here are the names of the machines, go and talk to all of them. Or you just have to have that job 5 times and name each machine. So it's not, the deployment capabilities aren't as rich as they are in Azure Pipelines or in tools like Octopus Deploy or something like that. So if you have complicated deployment scenarios, you might hit some barriers there. YAML is not fun, but that's not GitHub Actions, that's everything at the moment, so which he freely admitted. Workflow dispatch doesn't currently have any validation on it. I think that may have just changed. I think you can provide inputs and provide types for those, but at the time, there's no input validation, so you could hit the API to say, kick off a workflow, and then just provide garbage and the thing would explode, right? So there's not really any validation on that stuff. The documentation around context. So when you're running a job, there's a lot of information that you can get about what's happening. So there is a GitHub context that will tell you things like what was the event that triggered, what repository you're in and what the user is at the moment and what the machine looks like. There's a runner context that tells you all about the runner that you're on. There's a job context that tells you all about the job. So there's all of these pieces of information that you can pull out, but the documentation on them is not good. It's just not comprehensive. Some of them, like the GitHub context, it gives you a whole bunch of properties of that GitHub context, but it stops at a certain point and says, well, this is an object that represents a whole lot of information about about this part of that context. The solution is to convert it to JSON and dump it to the log. And I do that a lot to find out the piece of information that I want. But he said that especially is a failing in our documentation. We don't have all of that information. You kind of have to do some log debugging to work that stuff out sometimes. He also said that reusing workflows, private workflows, is really tricky inside an organization. I'll add to that as well. So in GitHub, you have to have GitHub Enterprise, I think, to be able to reuse private workflows from other repositories. Sorry, private actions or reusing workflows. Yeah. For GitHub Enterprise, you need to do that. I'll add to that, the environment support is also only available in GitHub Enterprise. So that whole thing about the approvals workflow, you're going to have to be paying for GitHub Enterprise to do that. Now, we need to make money, but the decision of where to cut that off is a legitimate complaint that comes up. So the environment support is GitHub Enterprise and above, which costs much more money. So there is that. And yeah, sorry, I did put that in. So enterprise features. There's some features that are only available to GitHub Enterprise, which means you're going to be paying us money. There's a lot of features that we have in GitHub that are kind of free for open source and public repositories. The environments one is not one of them for some reason. Things like Dependabot, which will check for your dependency vulnerabilities. So if you're using a package that has a known vulnerability, Dependabot is free for public repositories. There's some other features that are only available with GitHub Enterprise and only available with Advanced Security, which is an addition to GitHub Enterprise. So, I mean, the general message is there's some things that we give you for free and there's some things that you definitely have to pay for. And where that cutoff is may make sense to you or maybe a little bit too harsh. So just be aware of where those cutoffs are. And when you look at a feature, go and have a look to see what it's available on and whether you're actually going to fork out the money for it. All right. Quickly before we wrap up, we've got like 3 minutes, I think. What's new? So best way to find out what's new is on the GitHub blog. We have a changelog section for the blog, and you can say, show me all the action stuff that's new. Easiest way to find it. But in general, that getting started experience now analyzes your code to suggest good templates to start with. That's been improved a great deal. Reusable workflows is still a relatively new thing. So being able to have a workflow that knows how to deploy to Azure or AWS and then just reusing that across all of your workflows, that's definitely there. Sharing them in your enterprise, and this goes back to, it's a GitHub Enterprise feature, but you can share them across your organization. So your organization might have a way that you deploy to Azure. So from all your repositories, you can say, okay, deploy to Azure using our standard way of doing it. There's been a lot of improvements with the self-hosted runner as well. Basically some things around efficiency and the way it communicates and stuff like that. They're a bit behind the scenes, but it means the self-hosted runners are a lot more efficient than they used to be. And we can do things like partial reruns. So if a job fails in your workflow for whatever reason, you can rerun those ones rather than having to rerun the entire workflow, which is pretty handy. You can also just rerun the workflows and have multiple runs of that same instance of the workflow. So that's a new one. Some things that are coming, and again, easiest place to find them out is github.com/github/roadmap, which will take you to the repository that has all this information. But then github.co/roadmap is a board that is a project board that shows you all of the things that are available and what quarter they're going to be in. You'll find an Actions tab if you just want to filter it to those, or you can go through all of the things that are going to be available, drill into the issues to find out exactly what they are and what they're for. But a couple of highlights for me. Workflows at the organization and enterprise level. So again, the organization can define this is how we do actions rather than just having it in a repository and telling people this is the one you use. And at the enterprise level too. There's also some stuff around, enforcing some steps to run, workflows to run for repositories. So you may have a security check that you want every repository to run through. You can enforce, this is in the future, sorry. You can enforce a workflow to run for that repository. So the people working on that repository can't just choose not to include it. It'll always run on those repositories, which can be pretty handy in enterprise orgs. There's also going to be more powerful GitHub hosted runner options. So at the moment, you can't choose the size of that running machine, or that machine that's running. We are going to extend that. At the moment, it's just going to be build optimized ones, so you can choose the number of cores and RAM and things like that. Coming soon will be GPU optimized ones. So you'll be able to run like ML training workflows, for example, a lot better, or anything that needs a GPU. So that customization is coming as well. Obviously, that's going to affect pricing and how much you pay for these runners or how many minutes they use and things like that. At the moment, the only way to do this is to have self-hosted runners and have your own infrastructure. All right. We've gone through a lot of stuff. I think I'm 1 minute overdue. Here's where you can learn more information. GitHub Docs. GitHub Skills is a brand new kind of learning thing we just released about a month ago, and it's kind of tutorials going through how to actually use these things. And then Microsoft Learn actually has a bunch of stuff on GitHub Actions too. So it has learning paths on how to use GitHub and how to use GitHub Actions. Cool. I'll let Adam take his photo. I can give you these links later on, Adam, if you like. But that's all I had. I'm going to be around for the rest of the day. I know there's been a lot of questions about GitHub Actions, especially to me since I've been here. So if you have more, please hit me up. You can always reach me at DamoVisa on Twitter, or damovisa@github.com, or damovisa anywhere else, really. So thank you so much for your time. Have a good one.